Hello dear students, I hope you all are doing great. So welcome back to this channel, myself Madhu Yadav and I am a senior lecturer for zoology. And today I am going to discuss with you a very small unit, that is ecology. In this unit there used to be 4 chapters earlier, okay, but now one chapter has been reduced and now we have only 3 chapters to study in this unit ecology. So the very first chapter you can see is organisms and populations, okay. The second chapter is ecosystem and the third chapter is biodiversity and conservation. Alright, so now I will be taking 3 lectures in which the first one is about the organisms and population. The second one is about the next chapter and the third one. So like that I'll be making 3 lectures. So do watch all these lectures if you want to understand ecology, okay, the complete unit ecology. If you want to understand, please do watch all the lectures. So today we are going to discuss only organisms and populations, right? So let us understand ecology, okay. So what is ecology? This is a very easy unit which can be understood by anybody, okay. So ecology is nothing but study of interactions. So what type of interactions, okay, like the organisms, okay, the organisms are interacting with each other and not only with each other, the organisms are interacting with the physical environment as well, okay. So ecology is the study of interaction among organisms and between the organism and its physical environment. So what will come in the physical environment? What will come in the physical environment? Physical environment is nothing but the light, okay. Physical environment is the temperature, the sunlight, the soil, okay, all these things comes under the physical environment. So we are interacting with each other and we are interacting with the physical environment around us as well. So that is only we are studying in this unit and that is the meaning of ecology. Now ecology can be studied at various levels, okay. So the first level, we have 4 levels of biological organization, very important, direct questions. So here I have taken only the important things of NCERT and you have to focus only on the important lines of NCERT, okay. So please take your NCERT with you and please underline the important points. Like here they are telling you ecology at 4 levels, okay. So the first level is organism, second level is population, third level is community and fourth level is biome. So let me take you to the next slide and let me just explain you what is the meaning of organism, population, community, biome, ecosystem and what are the differences in between all these, right? So an individual is an organism, like I am an organism, okay, you are an organism. Each and every individual is an organism and an organism belongs to a species, okay. So this is an individual, you can see, we can call it an organism, okay. This is an organism belongs to a species, right. Now let us make a group and if we are making a group, we all are the organisms of same population or different population, okay. Like you are watching in a group or you are sitting in a class, so you all are belonging to human species only, I am also belonging to human species only, so we are making a population. That means population is a group of organisms, okay. Population is a group of those organisms which all belong to the same species. So here you can see a group, so population is a group of organisms of same species, they belongs to same species. You can see all of these are same, right? But now in a community, you can see this organism, you can see an octopus, you can see a different type of fish, you can see plants here, you can see crab here. So we cannot live like only one species cannot live at a place, okay. There are so many species which are living, Okay, so there are group of organisms from different species. So basically, we are living in a community. Okay, in a community, there will be organisms of same species or different species. Different species. In a population, there will be organisms of same species or different species. Same species, right? So in a population, there are organisms of same species. But in a community, there are organisms. This is also group of organisms of different species, Okay, so that makes a community. Now, when the community interacts with the non-living factors, that will make a ecosystem. So after community, what comes? Ecosystem. Till community, we have seen only the living things, okay? Only the living organisms we have seen. Only the living organisms. But here, you can see water also. You can see soil also. You can see light also. Light will also be there. Okay, you can see a rock also. This is a rock. So all these are non-living things, right? The abiotic factors, living organisms or living things are biotic, whereas the other things are abiotic. So in an ecosystem, there will be both the components, the biotic components as well as the abiotic components. This is an ecosystem. So first is organism. Organism is an individual. Second is a population. Population is a group of organisms of same species. I repeat again and again, same species everyone, okay? Then comes the community. Community is also a group of organisms, but these organisms belonging to different species, okay? So basically we can say community is a group of population. There can be different population, okay? For example, in this room where I am teaching, I am from one population, okay? Then there can be some flies, okay? They are making another population. There can be some lizards, they are making another population. So like at a place, there will be so many different populations. Organisms of different populations will be there, that is community. Now ecosystem means community plus abiotic factors. Community plus abiotic factors, that makes the ecosystem. Now, what is the next term? Biome. What is the meaning of biome? Biome means there is a large area in which, more than one ecosystems can exist. And in that large area, the environmental factors which they will be same. Okay, environmental factors like rainfall will be same. In this whole area from here to here, the rainfall will be same. The temperature will be same. Alright. So that makes a biome. So biome is a very large area where more than one ecosystems can exist, and these ecosystems, they are sharing the same rainfall, same temperature and same other climatic factors. Okay, so that is a biome. And if we collect all the biomes of the, the whole world, that makes a biosphere here. Biosphere. So from here, if I will ask you again, what are the 4 levels of biological organization? Yes, everyone. So first is organism, second is population, third is community, and fourth is biome. So these are the 4 levels of biological organization which I have written here: organism, population, communities and biomes. These are the 4 levels, very important. So you understood the 4 levels of biological organization. Now let us continue and let us go further and let us understand the important topic of this chapter, the only topic now. Okay, previously we have got so many things to study in this chapter. Previously it was a very long chapter, but now it has got reduced and now we have to study only the topic population. So you have to study only about population. Okay, so now I have just now told you what is a population. Population is a group of organisms of same species, right? So now that those organisms, the group of organisms of same species, they will be living in a well-defined geographical area. They will be living in a well-defined geographical area and they will be sharing the same resources. They will be sharing the same food and space, right? And they are not only sharing, they are competing with each other also. So they are sharing or they are competing for the same resources. And very important, they can potentially interbreed. Interbreed means what? They will reproduce among themselves only. Okay, an organism of a species can reproduce within the same species. It cannot reproduce with the another species, with the organisms of another species, right? So, here is the definition of a population. Population is a group of organisms of same species. First point. Second point is they are living in a well-defined geographical area. Second point. Third point is they are sharing or competing with the similar resources. They have the similar resources. And fourth point is they are potentially interbreeding. They are capable of doing the reproduction with the organisms of same species. So in a population you will see interbreeding. Okay. Now coming to the next point, group of individuals resulting from asexual reproduction can also be considered as a population. Here when we say interbreeding, we mainly refers to sexual reproduction. We mainly refers to sexual reproduction. But it's not like the organisms formed from the asexual reproduction will not be considered as a population. They will also be considered as a population. Here is written. Okay, the organisms resulting from asexual reproduction will also be considered as a population. And the last point is also a very important point, that the natural selection, the evolution, that's how evolution takes place. So natural selection is never, selecting, the nature is never selecting only a single organism. Natural selection is operating at a big level, not at organism level, it is operating at a population level. So natural selection operates at population level. This can be another important question, that natural selection operates at which level, organism level or population level or community level. So it is the direct line of NCERT, it is operating at the population level. Okay, coming to the next point, that is some characteristics of population we will study. For example, I will tell you 5 characteristics. These are called as population attributes. These are called as what? Population attributes. So, we will be studying 4 attributes, okay, 4 or 5. Birth rate is the first one. Birth rate. Then second one is death rate. Third one is age-sex ratio. Fourth one is age pyramids. And fifth one is population density. Population density. So these are the 5 attributes. Attributes means what? Attributes means characters. Characters, or you can say properties. Okay. So an organism will not have a birth rate or a death rate or a age-sex ratio. The population will have all these attributes. The population will be having all these characteristics. So now let us understand birth rate. What is the meaning of birth rate? Rate of the births, how many births are happening. So basically, simply we can say per capita births. Per person, how many births have taken place in a population. Okay, so let us take the example. This is the example of NCERT, in which NCERT is asking you one question, that if in a pond there were 20 lotus plants. Okay, how many lotus plants? 20 lotus plants. So the initial population is what? The initial population is what? We can say N, population size or population density is designated by capital N. So here N is 20, right? the original population is 20. 20 lotus plants are there in a pond. Now 8 new plants are formed through the reproduction. 8 new plants are formed. So now what is the new population? 28. Okay, the new population is 28, but how many births have taken place? 8. Total number of births can be called as natality. Total number of births can be called as natality, which is represented by capital B, whereas birth rate is represented as small b. So how we can calculate small b, birth rate? How we can calculate birth rate? We can calculate birth rate by dividing the total number of births by the original population. So how many total number of births? Can you tell me? 8 are the total number of births. And what is n here? What is n? What is the population density? What is the original population size? 20. So 8 by 20. You will get the answer 0.4 offsprings per lotus per year. Okay. So by the help of the example, I hope you have understood what is birth rate, how you can calculate birth rate. You need to know only two things mainly. Okay, how many total number of births took place and what is the total original population size. Original population size or population density, we can designate it as n. Okay, the birth rate is designated as small b, birth rate. Okay, whereas total number of births can be called as natality, which is designated as capital B. So we have got this formula. By this formula you can easily calculate the birth rate. So next population attribute is death rate. Okay, just like we have calculated birth rate, similarly we will be calculating death rate as well. So for calculating death rate, you need to know again two things: total number of deaths occurred and the original population size. Okay, so what will be the formula of calculating death rate? We can take death rate as small d and the total number of deaths, which can be called as mortality, which can be called as what? Mortality, and the population size, the original population size. Okay, that will be n, right? So let us take the example given in NCERT. If 4 individuals in a laboratory population of fruit flies, how many fruit flies are there? 40, but 4 died. So if from the 44 died, what will be the death rate? That we have to calculate here. Okay, so what is the D? What is D here? What is mortality here? 4. The total number of deaths are 4. Okay, and what is the population size? 40. So 4 by 40, very easy. 4 by 40. 4 by 40, you will easily get the answer 0.1 individual per fruit fly per week, because the lifespan of the fruit fly is a week, right? So that is how we have calculated birth rate and death rate. Birth rate is small b, death rate is small d. Birth rate is capital B by n. Death rate is capital D by n. Here capital B is natality, whereas capital D is mortality. And what is n? N is the original population size or original population density. So we have completed 2 population attributes, birth rate and death rate. Okay. Now let us understand age-sex ratio. So sex ratio also, an organism will not have the sex ratio. Okay, a population only. In a population of 100 individuals, we can say how many percent of males are there, how many percent of females are there. Okay, for example, if we say in a population 60% of the population is females, 60% are females and 40% are males. So we are telling the percentage of the male and female in a population, that will be sex ratio. And the next population attribute is very, very important and easy to understand, that is age pyramids. So when we study age pyramids, we are basically making a pyramid. Okay, we are getting a pyramid, you know pyramid. Okay, the base is broad and the apex is narrow. So here in this, when we are grouping the organisms according to their age. Okay, for example, we have grouped it into 3 groups. We have grouped all the organisms into 3 groups: pre-reproductive group, reproductive group, and post-reproductive group. Pre-reproductive group, the organisms which are not yet they are not matured to get involved in the reproduction, right? They cannot reproduce, they cannot give rise to offsprings. But reproductive is that group in which all the organisms can reproduce, okay? They can give rise to new offsprings, right? And the post reproductive means they have already done their reproduction, they have already done their job, okay, and now they cannot reproduce further. So now if you will see, according to the number of these age group organisms, we will have the shape of the pyramid. Okay, so you can see here there can be expanding population. In an expanding population, the population is increasing. Okay, so for developing countries the population is increasing. So you can see population is expanding because pre-reproductive are more. Okay, here pre-reproductive are more than reproductive, and reproductive are more than post-reproductive. Okay, so this is the situation. So expanding, we are here getting which type of pyramid? A triangular pyramid. What is the shape of this pyramid? Triangular pyramid. So triangular pyramid is telling you what about the population? The population is expanding. Now the population is increasing. Whereas if you see this pyramid, in this pyramid you can see a U-shaped pyramid or a inverted U or a bell-shaped pyramid. You can see what is the shape of this pyramid? Bell-shaped. Here you can say that the pre-reproductive is almost equal to reproductive. That means the population is not going to increase that much. It is not going to increase. So it is going to be stable because pre-reproductive and reproductive are almost same. So when reproductive will reach post-reproductive, the pre-reproductive age organisms are going to come into the reproductive age. So previously also they were same only, now also they are same only. So there will be no increase in the population density. Okay, so that means the population is stable. For developed countries, the age pyramid will be like this. Okay, the ecological pyramid will be like this. So it is a bell-shaped pyramid which is telling you that population size is stable. Population is not expanding. The population is stable. Whereas if you see the third pyramid, in case of the third pyramid, the pre-reproductive are less than the reproductive. The pre-reproductive are less than the reproductive, and then the reproductive are more than the post-reproductive. You can see. So it is an unshaped pyramid. It is an unshaped pyramid. It is unshaped. It is an unshaped pyramid in which you can see population is going to decrease because now the number of organisms in the reproductive age, they are more than the number of organisms in the pre-reproductive. When the pre-reproductive will come into the reproductive age, they will not be able to do that much, contribution to the population. They will be reproducing less, okay, because number of organisms are less. So that is why the population will be declining. So on the basis of 3 types of age pyramids, what we are understanding about the population growth status? The population growth status can be growing or expanding, can be stable, okay, and can be declining. So India has this type of pyramid, okay. India is a developing country. It is not a developed country yet, but for the developed countries like US and Japan, you will see stable or declining. Their population is stable or declining, right? So that is all about age pyramids. It is very easy to understand age pyramids. And now coming to the population density. This is the 5th attribute. Till now we have done 4 attributes: birth rate, death rate, sex ratio, age pyramids, and now the fifth attribute is population density. So basically population density means nothing but population size only. We can count the population in numbers, we can measure it in biomass, the weight, biomass, okay. So there are different measures of population density. Population size in a given area is technically called as population density, is technically called as what? Population density, and it is designated as N. I have already told you it is designated as N. So it can be very low, it can be in millions, it can be very high as well. The number of the population, the number of organisms in a population can be very less, or it can be very high. For example, less than 10 Siberian cranes are coming in the Bharatpur, Rajasthan, Bharatpur wetlands. Okay, when they are migrating, so they are coming to less than 10 birds are coming, less than 10 Siberian cranes are coming. So at that time their population is having very less N, less population density. But it can be in a pond. If you see Chlamydomonas in the pond, it is in millions. So the population density can be low, can be very high. Okay. Now it can be measured in number, as I have told you, we can count. It can be measured in biomass, and it can be measured in percent cover, how much area it is covering. Okay. So how much area it is covering, how much weight it has, and how many in number. These all can be the ways to measure the population density. Okay. So population density can be measured in three ways. First is the number. Second is the biomass or the weight. Okay, the weight of the organic matter. And the third is the percent cover. Okay, sometimes when we are not able to count them properly, because sometimes it will be very difficult to count. Okay, so in such cases the relative population density will also serve the purpose equally. So it's not like we have to always measure the absolute population density. No. Sometimes we can take the relative population density as well. Okay. So relative population density also serves the purpose equally. So there can be an absolute population density, there can be a relative population density. Okay. So now, how to determine population growth? So population growth is dependent upon four factors. Okay. In the population is a group of organisms of the same species. So in that group of organisms, how many new organisms are getting formed? How many new organisms are taking birth? So that is natality, births. Okay. How many organisms are dying? That is mortality. Now in that population, from the another population, from somewhere else, if few organisms are coming, that is immigration. Okay. And if some of the organisms, they are not liking that population and they want to go away from that place and they want to go somewhere else. Okay. So they are just going from that population. So these are the four things. Okay. The first thing is natality, second is mortality, third is immigration, and fourth is emigration. E, exit, E for exit here. They are going out. Immigration, I, here in, they are coming into the population, they are going out of the population, right? Mortality means deaths, how many total number of deaths, and natality means births, total number of births. So don't get confused, natality is represented by capital B, not capital N. Remember this. Capital N is our population density. Okay. So now if NT plus 1 we have to calculate. Okay. After some time, after a period of time, if we are calculating the population growth, how much population has grown. So that depends upon these four factors. So what we will do, the population size at time t, in that we have to add two factors because these two factors are increasing the population density. Okay. What are the two factors which are increasing the population density? the natality and the immigration. But the two factors which are decreasing the population density are the capital D means mortality and capital E means emigration. They are going, okay, they are going. So there are four things. So that's how you will calculate the new population density for any population. If they will give you the total number of births, the total number of deaths, the total number of people came, the total number of people went, in this way you can easily calculate the population growth. How much is the population growth, right? Very easy. Now, under normal conditions, if somebody will ask you under normal conditions, what are the most important factors, okay, for the population growth? So the most important factors are births and deaths, obviously. But when a new habitat is getting formed, when a new population is getting formed, at that time the immigration can also contribute more than the birth rate, okay. So otherwise births and deaths will be the more important factors. But in a condition where it is telling you that a new habitat is getting formed, maybe so many people will come at a time. If we will say in taking birth it will take more time, but simply coming from somewhere else, the group of organisms coming from somewhere else, it will not take that much time, right? So in that case, immigration will be more important as compared to the birth. Alright, so that is about the population growth. Now we have to see the growth models. So we have two types of growth models. One is exponential growth model, one is logistic growth model, okay. It is just like one is dreamland, okay. We think about our dreams, we think about getting a new house, getting a new car, getting so many things in our house, okay. So much we think, okay. So that is just we think that we should have this, that, so many things, okay. It is just exponential growth. It is just like exponential growth. When a population is having unlimited resources, unlimited food, unlimited water, unlimited resources, other resources, space, habitat, okay, when everything is unlimited, unlimited resources are there, then population will not stop. It will keep on growing, and we will get a J-shaped curve like this. This is a J-shaped curve. You can see this equation is about the exponential growth. This is exponential growth equation. Exponential growth equation, okay. So this exponential growth curve is a J-shaped curve. You can see is a J-shaped curve. And what is the equation? Change in population density with time. dN by dt means change in population density with time. How we can calculate that? R into N. What is R here? R is the very important factor. R is the intrinsic rate of natural increase. Intrinsic rate of natural increase. How we can calculate R? We can calculate R by minusing the death rate from the birth rate. B minus D, small b minus small d. Small b is birth rate, small d is death rate. So R, it is also called as Darwinian fitness. You know, every species, every population wants to increase their R. Okay. So R means R will be more when the birth rate will be more than the death rate. So B minus D, that's how we calculate R. So here the change in population density with time is equal to R into N. R, I have told you how to calculate R, okay, and I have already told you how to calculate birth rate and death rate. That is also very easy. So, and N, you know already, N is population density, So we are plotting the graph of the population. We want to see the change in the population density with time. Here we are taking time, and here we are taking population density. So with time, population is increasing. But it is not possible. It is just the dreamland. We can think about it. But it is not possible because we never have unlimited resources. The resources and the space is limited. The resources are finite. Okay, they are not infinite resources. Okay, so now the more realistic curve is this curve, which you can see with the here with the shape similar to S. This is a sigmoid shape curve. Okay, this is a S-shaped curve or sigmoid curve. So in this curve, you can see that population density is increasing with time, but it is not increasing beyond this point. So what is this point? This point stands as carrying capacity K. What is carrying capacity? Carrying capacity means only this is the number of maximum individuals supported by that habitat. Okay, not more than this. This habitat cannot support more than these number of organisms. That is carrying capacity, maximum number. Carrying capacity. So population cannot grow beyond carrying capacity because that is the capacity of the nature. Okay, this is nature's carrying capacity of supporting the number of individuals, the number of organisms, right? So here we have to add this also. Okay, till here it is same. This is logistic growth equation. You can see logistic growth equation. Direct questions are coming from here. This growth curve is very important. So logistic growth curve is not J-shaped, it is S-shaped first of all. And here what is the important factor? K is the important factor. So dN by dt is equal to Rn. Till here it is the same. But we have also included into K minus N upon K. What is K here? K is carrying capacity. So what is exponential growth equation? dN by dt is equal to Rn. I have told you what is R and how to calculate R. Okay. Whereas what is logistic growth equation? dN by dt is equal to Rn into K minus N upon K. K minus N upon K. So what is K here? K is the carrying capacity. What is K? K is carrying capacity. So I have written all this thing again. Okay. So let us read this. Two growth models we have. Okay, I have told you one growth model is exponential growth model. Exponential growth model is J-shaped. So this growth model we will see when there is unlimited food and space, unlimited resources. All right. And what is the equation I have told you? dN by dt is equal to Rn. So how we can calculate R? R is small b minus small d. What is R? Intrinsic rate of natural increase. So in NCERT, 3 values are given which you have to remember exactly like that. And direct questions will be coming. Like for Norway rat, the R value for Norway rat is 0.015. The R value for flower beetle is 0.12. And the R value for human population in India in 1981, the R value is 0.0205. 0.0205. So these 3 R values you have to remember. Direct question can be asked from NCERT. Now since this equation is very small, they are giving us one more equation to learn, and that is the integral form of this dN by dt is equal to Rn. So the dN by dt is equal to Rn, this equation, when we will take the integral form of this equation, we will get this equation. We will get such type of equation where you can see Nt is equal to N naught ERT. E raised to power RT. What is E here? E is the base of natural log which you use in physics and chemistry. Right? What is Nt here? Nt is the population density after T time. And what is N naught here or N0? Population density, original population density. Population density at time 0. Okay, so R and T you know already. R is intrinsic rate of natural increase. So how many equations you have to remember for exponential growth curve, everyone? 2 equations. One is the normal equation, dn by dt is equal to Rn. Second is the integral form of this equation, nt is equal to n naught e raised to power rt. This is the integral form of this equation, exponential growth curve equation, integral form. Okay, now what I have written here, the another name of logistic growth, the another name of logistic growth curve is Verhulst-Pearl logistic growth. It is sigmoid or S-shaped, and obviously it represents that the food and resources are limited. Okay, so that is the more realistic one. This is the more realistic curve. Among these two, if somebody will ask you which is more realistic, so then you will say logistic growth, logical, it is more logical, more realistic. Okay, so it is logistic, and dn by dt is equal to Rn into dn by dt is equal to Rn into, here is into k minus n upon k. Okay, this is the only one equation you have to remember for logistic growth curve. Okay, you know what is K? K is carrying capacity. Very, very important. Very, very important factor in the logistic growth model. K, carrying capacity. What is carrying capacity? Maximum number of organisms that can be supported by the habitat. Okay, I hope you have understood these two curves. Okay, from the graph is very, very important. The exact graph is given in the NCERT, and they can even give the graph in the question, and they can label it A, B, C, D somewhere, or simply A and B they will label, and they will ask you which curve is for, which curve represents A and which curve represents B, like that. Okay, exponential growth is represented by A or B, like that. So if you can see A here, A is for logistic growth, B is for exponential growth. Here A is the when the resources are limiting, then the growth will be logistic. Here the plot is logistic, K is the carrying capacity, whereas when the resources are not limiting, then the growth will be exponential. I hope this is understood by everyone. Now the one last topic, that is life history variations. Okay, so different organisms have their different strategy. Okay, for example, here we will be talking about 4 strategies. And why they have these strategies? Because they want to increase their fitness, because they want to increase their R. R is the intrinsic rate of natural increase. So organisms, they will evolve. Evolve means evolution. By the evolution they will change themselves. Why they are going to change themselves? So that they will be fit in the nature. Okay, so that is also called as Darwinian fitness, high R value. To achieve this high R value, there are different strategies adopted by different organisms. For example, the first strategy is some organisms will reproduce only once in their lifetime. They will not reproduce many times, they will reproduce only once in their lifetime. For example, Pacific salmon, for example, bamboo. These are the examples. Very, very important. Direct question can be asked. Okay. Another strategy is multiple times they will breed. They will breed many times. For example, us, mammals, birds. Okay. These will breed many times. So this is another strategy. Some organisms, so which strategy is good, we don't know. Okay, whatever, it depends on the organism, it depends upon the species, it depends upon in which habitat they are living. So according to that, they have adopted different strategies. Okay, another strategies is the so many offsprings, they will produce so many offsprings of small size. Okay, so they are going to, some organism, they are going to produce a large number of small sized offsprings. For example, oysters, For example, pelagic fishes, what they will do? They will reproduce and they will produce so many large number of offsprings. But all those large number of offsprings are very, very small. So maybe since their offsprings are very small, they are producing in large number. Okay. Another strategy is production of small number of large size offsprings. Just like birds and mammals again. Birds and mammals reproduce multiple times and they give rise to small number of large sized offsprings. Okay, birds and mammals. So these we can say those which are reproducing and giving rise to large number of small size offspring, they are R-selected species. These species are R-selected species. They are going to increase their R. Okay, whereas K-selected species, if you say, they are depending upon the carrying capacity. Okay, they cannot increase more than the carrying capacity. Human population is also near to the carrying capacity. Okay, it has reached near to the carrying capacity. So that is why birds and mammals, they are giving rise to small number of large size offspring. So these are the 4 different strategies given in the paragraph of life history variation. Now after this, only one more topic is there, that is population interactions, which is a very interesting topic, and I have talked about that topic already in this channel. Okay, Sri Chaitanya Goshala. So you can go to the videos which are there in this channel already, and you can see the population interaction topic as well, which I have already taught, okay, on this channel. So that was all about today's class. If you have understood everything, please like this video, and for more updates, just subscribe to this channel. And that is all about today's class. Thank you very much.